Good morning, students. I am Dr. Raju Anita, Faculty for Artificial Intelligence. Today we are going to learn the session number 12, cryptarithmetic problems from CO2. Now I would like to show you the PPTs. So what is the last session we discussed? The last session we discussed was constraint satisfaction problems. So while we are playing any game, if there are any constraints you are keeping to play that game, that games comes under constraint satisfaction problems. These are the cryptarithmetic problems comes under constraint specification problems or constraint satisfaction problems. So these cryptarithmetic problem, how we are going to solve these kind of problems? So see here, the problem was given 2 to 4. Suppose I want to send a message for another person. I think all of you are very clear about encryption and decryption. I want to send a message for another person. So without sending direct message, just I would like to encrypt that message and I want to send that message for another person. So the other person is going to decrypt that message and he could able to understand what is the first person send the message for them. This is called encryption and decryption. Yes, encryption and decryption we are going to do in cryptarithmetic problems. So as I told for you, these cryptarithmetic problems comes under constraint specification problems, CSP problems. That means while you are solving these problems, they are having some constraints. Based upon those constraints only, you need to solve these kind of problems. So let us go for the example. Here they are given 2 to 4. That means this is encrypted, right? So 2, 2 and 4. So we need to decrypt this. So what it will be the values for this? We need to decrypt this message under CSP, under some constraints. What are the main three components we discussed for constraint specification problem? The first one is a set of variables. The second one is domain. The third one is constraint. Here, this constraint specification problem mainly depends upon three components. The first component is variables. The second component is domains. And the third component is constraints. So once the problem is given, you should have to identify what are the variables, what are the domains, and what are the constraints it was given on that particular problem. Right. So now we are going to solve this problem 2 to 4. Right. Now I would like to use this board to explain this problem and be clear this. Here, what is the problem it was given? 2 and here 2. Thus it was giving it as 4. So here we need to solve this problem. So while you are solving this problem, first we need to understand what are the variables. So here x, what is the variable here it was given? So the variables are t, w, o, next. Here next F, you should not use the repeated letters. Just write all the letters only once. F and O is already came. So I am not writing O. And U and R. Right? These are the characters or alphabets that was given without any repetition. So for this you need to identify the values that was assigned for this. So we need to identify the domain. What the values you have to assign for these variables. The values which you are assigning for these variables is 0 to 9. You have to assign 0 to 9 digits only for each and every alphabet that was given here. While you are assigning this 0 to 9, the constraint here is you should not repeat any digit for any alphabet. That is the constraint I am giving here. Next, we have another constraints. What are the another constraints here? The other constraint is if you are adding any two numbers, the sum it should not cross greater than 19. Right? Why? Because we are using only 0 to 9 digits. If we are using 0 to 9 digits, the sum of those any digits it should be less than or equal to 19 only. We are not getting any greater than 19 the sum value. Next, we can have that means we can have any generation of carry. So we can generate any carry. Suppose here I am adding two numbers. So it was came as 19. What is here one is called it as carry. Right? So any two numbers, if you add, a carry can be generated. That is the next constraint. And the next constraint is for all possible values, you can select the minimum value for the possibility in the given domain. So if you have a domain value, in that domain value, first give the priority for the minimum value. Right. And one more you need to remember this is no digits should lead with zeros. So for example here this is a 3-digit word and this is a 3-digit word. Suppose if I am taking t value as 0, what it will happen? It will become 2-digit number. So you should not keep any leading zeros for any numbers. Right? That is another constraint. Based upon these constraints, we are solving the problem. Right? Understood? Now I am starting to solve my problem. So here this one d plus o is equal to r. So by adding these two, it can generate a carry. Suppose here I am writing C1 is a carry which is generated by DO, and if you are adding W, W and C1, there may be a possible to generate a carry that I am calling it as C2. Yes, if you are adding C2 plus T plus T plus O, there may be a possible to generate a carry C3. Right, I am writing C3 here. So now, how could you write in the form of constraint here? So I am adding D plus O. Right, D plus O is equal to, sorry, O plus O. This is O, not D. 2 plus 2. O plus O is equal to R plus 10, because here if it is generating a carry, in the sense the value of that R, it may be greater than 10. So that's why I am writing 10 into C1. So if the C1 is 0, C1 is the carry. It can be 0 or 1. Right? If it is 0, then R is a single digit number. If it is a 1, R will become the double digit number. Right? The next, what is the next constraint? C1 plus W, right, is equal to U plus 10 into C2. 10 into C2. This is the another constraint. And next, what is the next constraint? C2 plus T is equal to O plus 10 into C 3. This is another constraint. Next, C3 is equal to F. These are the constraints we are having on this. Right? Now here, based upon this, you are going to identify what the digits you are assigning for the each alphabet. Right? Now first, so here, what I told for you, for any number, the leading value should not be 0. Suppose if you are taking F value as 0, then it will become 3-digit number, but it is a 4-digit number. So always F it will be 1. So I am taking F value is 1. The next one is, whenever F value becomes 1, we need to concentrate to calculate T value. And here F became 1. So you can design a table like this and you can assign all the values for the given alphabets. What are the alphabets here? What are the variables I have? T, W, O, F, U, R. These are the variables I have. So already I identified F value 1. So no other value should have the same value, F value 1. You should not assign one value for any other alphabet. That you need to remember. Right? The next thing is here. Now I need to calculate. One more thing we have to observe. We can evaluate this problem from left hand side or right hand side. That is the possibility where you can do. So now next I am taking T plus T. So what is the T possibilities here? T should not 0 or 1. So these two possibilities are not there for T. Why? Because if you are keeping 0 value for T, then it will become the leading number as 0. So you should not keep it as 0. 1 you should not keep for T. Why? Because 1 is already allocated for F. So what are the domain values, the possible domain values for T? What are the possible domain values for T? There is a possibility for 2, 3, 4, 5, 6, 7, 8. These are the possibilities that we have for the t. Now what I said for you, in these possibilities you need to select the least possibility value first. So which one is the least possibility value here? 2 is the least possibility value. So I would like to take 2. If you are assigning 2 here, 2 plus 2, it will become 4. So but it is not generating the 2-digit number. But as per our constraint here, C3 should be 1. This should be 1. That means the O value has to be 2-digit number. But if you are taking T value 2, it is producing only single digit number. So there is no possibility for 2. Next, take 3. 3 plus 3. This is also giving the single digit. So, there is no possibility for 3. Next, take 4. 4 plus 4. That is also giving 8. No possibility. And now I am taking 5. 5 plus 5, 10. Yes, there is a possibility. So, if you are taking t value 5, what will happen? T plus t is equal to O. That means t plus t. 5 plus 5, 10. 1 it will be go here and 0 will be assigned for O. But here, whenever you are coming for the last pattern, that is O plus O equal to R. What is the meaning of O plus O? If you are assigning 0 for O, 0 plus 0 is equal to R. That is equal to 0 is equal to R. So, the two alphabets T and R is having the same value, that is 0. But it is not possible to give the same value 0 for two different alphabets. So there is no possibility for 5 also. Now we have to give the possibility for t equal to 6. After this understood? So first you are taking f value 1, then after you are calculating t value. So up to here we are checking all possibility values here. Once I found the possibility value, what is the possibility value here I identify for t? There is a possibility value for t is t, it can be 6, 7, 8, 9. So, right, these are the possibilities for t. Now, what I told for you, we have to select the minimum value for t. 6. I am giving t value equal to 6. If you are giving t value is equal to 6, so what it will be the O value? O value is equal to 2 because 6 plus 6, 12, 1 is carried and 2 will be given to O. Now, go for last and then go for this one. O plus O is equal to R. What is O plus O? 2 plus 2. That is equal to R becomes 4. Okay. Now T became 6, O became 2 and R became 4. Keep it aside. This is I am keeping aside because I found 3 values. Don't fix it. We need to check another constraints also. If those constraints also satisfy, then only we need to fix these values. Now we are going for W plus W is equal to U. Right. So W plus W is equal to U. What are the possibilities for W? W I am taking the possibilities. 1 is completed, already 1 completed and 2 completed, 4 completed and 6 completed. What are the possibilities for W here? 3 is one possibility and 2 is 0 is one possibility. Yes, 0 is one possibility and 2 is another possibility. No, I assigned 2 for O and 3 is another possibility and 4 is another possibility. No, because I assigned 4 for R is equal to 4. There is no possibility. Next I can give it as 5 and 7, 8, 9. Right? These are the possibilities. So if you are taking 0, what it will happen? 0 plus 0. U also becomes 0. So there is no possibility for 0 also. Right? 3. If you are taking 3, what it will happen? 3 plus 3 is equal to U. That is equal to U becomes 6. Is it possible to assign 6 for U? No, because already I was given T equal to 6. Then where is the possibility for you to assign 6 again for U? So the constraint is failed. Again go for this 3 is not possible and go for 5. If you are assigning 5 for W, then what it will happen? U becomes 0. U becomes 0. So if U becoming is 0, then here the problem occurs because here you are not generating anything. So here the possibility is not there for this number. Like that you have to check all these possibilities. These possibilities are not satisfying this constraint. when the problem occurs here, whenever you are taking t equal to 6, the problem arises. So you should not assume t equal to 6. So what is the next possibility to assume the t value? The next possibility is 7. So I am selecting 7 here. I am selecting t value is equal to 7, right? So if I am taking t value 6, there is a problem occur. Now I am selecting next t value is 7. So whenever you are selecting t value equal to 7, then what it will happen? O value becomes 4, right? And what is R value? R value becomes 8. Keep it aside. Now come for W plus W is equal to U. So now what are the possibility domain values for W? I can give 3 and I can give 5, I can give 7, I can give 6, I can give 8, I can give 9 because 8 is already given. So 3, 5, 6, 8 only I could able to give for W value. So now I would like to assume the minimum value 3. So 3 plus 3 is equal to 6. Now U became 6. Is there any constraint that you could not give U value as 6? No, there is no constraint because 6 is not allocated for any variable. So I can give it. So all the possibilities I verified. Now what the value I was given for t? I was given for t is 7. And what the value I was given for 0? O, I was given 4. And what the value I was given for u? 6. The value I am giving for r is equal to 8 and w equal to 3. Now you can check it. Is there any repetition of digits came for alphabet? No repetition came. And is it is satisfying the problem which it was given? Now check it. Is it is satisfying the problem which it was given? The problem is here is 2 plus 2 to 4. So what the values I identified for 2? T is 7 and W is 3 and O is 4. 7, 3, 4, 7, 3, 4 and then here 8, 6, 14. So 14, 6, 8 I identify, I decoded. This is the way how we are solving the problems, script arithmetic problems. Understood? And one more problem here, there is a repetition of letters, it is there. So you could able to solve this is very easy, but some kind of problems it will be different. I would like to explain one more problem which the pattern of that problem is different. So the problem here is one more problem I am explaining about cryptarithmetic, that is send more is equal to money. Right? So this is the problem. So if I am writing exactly, then you could be able to understand exactly what is the digits, number of digits it will occur. Now send more and here this is equal to, wait a minute, I would like to erase this and I would like to show you here the second problem, how it will be. S-E-N-D, send, and this is M-O-R-E, more. Send more, and this is M-O-N-E-Y, money. So this is the problem it was given, addition. This is the problem it was given, how we are going to solve these kind of problems. As I told for you, first you need to design the variables. What are the set of variables that was given for you? So without repetition. So first write S-E-N-D, send. And next money, more, M-O-R. R, E already came. So I am not writing here. And next, Yambo is already came here. Yambo is already came. And N also already came. E already came and Y. So this you need to identify the letters for this. What are the constraints here? The same constraints. 0 to 9 digits you need to allocate for each and every alphabet, and the sum of any two letters, two digits, it should not cross more than 19. Alright, that is the second constraint. And the next one is it can generate the carry, either C1, C2, C3, C4, it can generate the carry. This is the constraints I am giving for you, and based upon the constraints we need to evaluate this problem. So first, as I told for you, this is C1, C2, C3, C4. These are the carries. C4 carries. So here in this, first of all, how we are writing the formulas here? D plus E is equal to Y plus 10 into C1. So this is the first. And next, what is the second one? N plus R. So for this N plus R, you need to add C1. C1 plus N plus R is equal to E plus 10 into C2. This is the second one. And how could you write the third one? C2 plus E plus O is equal to N plus 10 into C3. Next, C3 plus S plus M is equal to O plus 10 into C4. Next, C4 is equal to M. As I told for you, C4 is equal to M. Now here you are checking here. M is 1, ultimately 1, because here M came in the sense there may be a carry. Definitely the carry is there. So that's why it is came it as M. So that is not a 0, M. So I know that M is 1. I fixed that M is equal to 1. What are the domain values? 0 to 9. Any digit you have to assign 0 to 9. No repetition should be there for any digit for any alphabet. Okay, M is equal to 1. Now here replace wherever the M value is 1, replace here. So there is a M value. This M value I am replacing as 1. If you are replacing M value 1, what it will be the S value? What it will be the S value to generate a carry? So what are the possibilities for S? So the possibilities for S is 0, 2, and so on 9. Right? There is no 1 because M already 1 I assigned for M. So what it will be the possible value to generate a carry if we are adding that number 1? So 9 is only possibility. 9 plus 1 equal to 10. So S value you are fixing as 9. So I am fixing X value 9. And then here I am using this with S value 9. Whenever you are keeping S value 9, 9, 1, 10. So 1 carry and this is 0. Already we know O value is also 0. So 9, 1, 0 I fixed it. Now you need to find the next letters. So what is the next one here? E plus O is equal to N. This is E plus O equal to N. So if you are writing here, O value already we know that is 0. If you are adding 0 for this is O value and I know that is a 0. Is equal to N means E equal to N. Is it is possible to give the same value for two alphabets? No, this is failed. So definitely this is not correct. So it may be the carry. So that means C1 plus, C2. Here I am writing C2 plus E plus O is equal to N. That there may be a carry. 1 plus E plus 0 is equal to N. Then you can write 1 plus E equal to N. There may be the possibility of like this. So keep it aside. 1 plus E equal to N. I am keeping it aside. So next you are going for N plus R. N plus R is equal to E. So this is the problem. So I can write this as E plus 10. Right? Why? Because why I am writing E plus 10? There may be the possibility to generate a carry. Definitely N plus R is generating a carry and it is that carry it is passing to E O. So that's why I am writing N plus R equal to E plus 10. So and there is also one more possibility, 1 plus N plus R is equal to E plus 10. Why this possibility is there? So this N plus R also having a carry. So maybe D, E, after adding D and E, it may produce one carry for that. That I am writing. These two possibilities are available here. So in this, I would like to replace the equation 2 in equation 3. So now I am replacing N plus R is equal to e plus 10. What is n? I am replacing this value here. That is 1 plus e plus r is equal to e plus 10. So whenever you are replacing, what it will be the r value? R value will be 9. Is it possible to give the r value as 9? No. Why? Because already the r value 9 is given to s. S value is already 9. So it is not possible to give the R value as 9. We should not give 9. So when it was happen, if you are replacing this n value here in equation 3, we got that kind of problem. So if you are replacing the equation 2 in this second constraint, then what it will happen? Let us see. So let us replace. Now 1 plus n plus r is equal to e plus 10. Now I am replacing n is equal to 1 plus e plus r is equal to e plus 10. So how we are getting here? If you are striking off, r value is equal to 8. Now r value is 8. It is acceptable. 8 is acceptable because I didn't allocated 8 for any other alphabet. So I can give it as r as 8. So if once you are having r value 8, then immediately you can replace nr. I know here r value now. Now n plus r is equal to, I know r value, you can replace r value here. You can replace r value here. Now I have to decide what is d value and e value, because if you know d value, e value, then only I could able to know what is the n value. So de, go for d plus e is equal to y. So what are the possibilities, the values that I can give for d and e? Now I am writing r value is equal to 8. Now I need to find the rest of numbers. To find the rest of digits, I need to check what are the possibility values that are available for D and E. So that means I need to check what are the domain values that are existed for D and E. So now check it. So first I am giving D value is, what are the D values? Possible values. D, is it D can be 0? No, it cannot be 0, because if you are keeping 0, it will come only single digit. But D plus E has to generate a carry for NR. So it is not possible to have 0 as a domain value. 1, is it possible to give 1 value for D? No, we cannot give the 1 value for D, already it was assigned. I can give an D value 2, and I can give 3, 4, 5, and then 6, 7. These are the possibilities for D. And as well as E also is having the same possibilities, 2, 3, 4, 5, 6, 7. Right? So, but now you need to observe D plus E is equal to Y. That means the Y value, maybe it will be 10 or 11 or 12 or 13, like that, and so on. Right? Why? Because already we know D, after adding DE, it has to generate a carry. That carry you are passing for the next NR. Right? So now, is it possible to take 10? No, because if you are taking 10, Y becomes 0. Right? It is not possible. 0 already I assigned for O. Now this is no option. Now 11. Is it possible to give the 11? If you are giving 11, then the addition, if it becomes 11, the y value will be 1. So no possible, because I assigned already m value 1. So there is no possibility for 11 also. Now go for 12. Yes, there is a possibility to have the 12 or 13 and so on. Now if you are taking the combination of any these values for D and E, which combination it is giving the values as 12 or 13 or more than that? There is only two possibilities. 6, 7 I can give, because this is 13, and I can give 7, 5 because this is 12. Right? Only these two possibilities are there for addition of any two numbers, which I will get the value more than 12. 12 or more than 12. Right? Now assume, if I give D value, what will happen? D I am giving 6 and E I am giving 7. What will happen? 6 plus 7. What is 6 plus 7? 13 will come. So Y value will become 3. Right. If y value becomes 3, go for the next statement. N plus r equal to e. So what is n plus r here? So if you are having already 1 is there, 1 is the carry, and r already I know 9, and that is equal to 3. So 9 plus what the value I can give 9 plus if you will get the 13, 9 plus 4 I have to get, right? 9 plus 4 I have to get. N value is 4. Again, I know E value is E plus O, that is 0, that is 1. 1, 3, 4. Again, N value becomes 4, but it is not possible to get the same value twice. So, here this possibility, there is no option to take this possibility. So, I am not taking 6, 7, 13 possibility. Now, I am taking the next possibility, that is 7, 5. So if you are taking 7, 5, what it will happen? So D value I am taking it as a 7 and E value I am taking it as a 5. So if you are taking those two values for D and 5, what it will happen? 7 and E equal to 5. So check it. 7 plus 5, 6, 7, 8, 9, 10 will come, right? 13. So 12. Right, more than 10, that is 12 came. So now y value is 2 and this is 1. There is no one on there, only one option. So there is no another option. So definitely it will fix 7, 5 and this y value is equal to 2. What is the n value here you will get? N value definitely we will get as 6. Why? Because 1 plus n plus 8, that is equal to E. What is E? 5. So 15 has to come. Right? So 6. So these are the individual digits it came for to identification. Now you can write it as what the values I identified here for SE and D. So I identified here for SE and D is, so here I wrote SE and D is here, S is 9 and here I'm substituting those values. S is 9 and then E is 5. Wait a minute, it is under erasure. Still, I'd like to take 9 and E is 5 and N is 6 and D is 7 and then M is 1 and O is 0, R is 8 and E is 5. So next M is 1 and O is 0 and N is 6 and E is 5 and Y is 2. So it will come like this. This is the answer for this solution. Understood? So this is the way how we are solving these cryptic arithmetic problems. So these cryptic arithmetic problems, it will give for you for any kind of example. You should be in a position to solve. There may be a problem of base bar. It will give the games. Or otherwise you heart. They will give. The only one thing you need to remember is you have to remember the constraints while you are solving your problem. Right? The next one is backtracking search. What is the meaning of backtracking search? So are you are observing the previous examples, while we are solving the problem, just we are going back and we are cancelling our assumptions. Right? Here variable assignments. So whenever you are assigning the variables, values for the variables, then it is following the commutative law. What is the meaning of commutative law? 2 plus 3 is equal to 5 and 3 plus 2 is also equal to 5. That is a commutative law. AB is equal to BA. That is a commutative law. So here if we are assigning the red color for WA and green color for NT, so even though if you flip it, NT is green, then WA equal to red. These two are the same. Only need to consider the assignments to a single variable at each node. So at each node you have to assign a single variable. So if you are using the depth first search for constraint specification problems for a single variable assignment, that is called as backtracking search. What is backtracking search? So you are using the depth first search for constraint specification problem with a single variable assignment. For every variable you are assigning a single value. That is no repetition of any value. That is called it as backtracking search. Right? With this backtracking search, you can solve the NP remaining problem also. Now this is an algorithm for how we are using the backtracking search. So here this is the function for backtracking search. So CSP, what the constraints you are specifying while you are doing backtracking search, you are specifying the constraint. Then after it is returning either a solution or a failure. So if it is having a solution, it will return that solution. Otherwise, it may be written that is a failure. Because in what cases there may be a possibility of failure if you can't apply that constraint. If you are not able to go by following that constraint, if you are following that constraint, I can't able to move further, then it is called as a failure. And what it is returning, recursive backtracking. So recursively you are applying the same thing. That's what we are returning, return recursive backtracking. So this is the function for recursive backtracking. So for this, first you are going for assignment, what the values you are assigning for the each variable, and the constraint specifications. What are the constraints you are specifying for that problem to solve. First, if assignment is complete, suppose I assign one value that is satisfying all the constraints, then immediately you are returning that assignment and you are fixing that assignment is correct what I did. Next, if that assignment is not complete, what we have to select, you need to select unassigned variables. Suppose here already I assigned 9 for S value, then you should not assign again 9 for another alphabet. In that cases, you need to go for unassigned variables. So here I'm going to use select unassigned variable function for to assign the unassigned variable. Where it will be unassigned variable, here we have variables as CSP. What are the variables that are there which it is having in constraint specification problem and assignment, and this is the constraints. So for each value you have to check the domain values. So I want to assign a value for the variable. So how you are going to check? First of all, you have to check the possibility of the domain values. What are the possibilities in the given domain values? So based upon the possibilities in the given domain values, you are going to do the assignment. That's what we are doing here. And next you are repeating the same procedure until you are getting the result. Otherwise it is returning failure. This is the backtracking search algorithm. Example, how we are going to take an example in the graph coloring map. So here see, this is the given empty map it was given. So totally I have three colors. I need to assign the three colors for this map, and the constraint here is no two adjacent regions have the same color. So first I am writing all the possibilities here, the three possibility colors. Next, here in this depth first search I am using, so you can observe here. Next, here I am assigning a green color here, and the possibility is red, blue color. There is no possibility for red color. So I used these two. Next, what are the possibilities here? After green, I can assign the here red color. I can assign the blue color here. This is the possibility. In the same manner, you can check all the possibility values in the depth first search in backtracking. So what is the advantage here? So the main advantage here is you can immediately identify where it is not possible for us to assign a color which it is violating the constraint. Then you can immediately identify. Improving backtracking efficiency. How could you able to improve the backtracking efficiency? General purpose methods can give huge gains in speed. Which variables should be assigned next? What are the variables we can assign next? We could able to understand. In what order should its value be tried? So in what order we can try the colors? That we can able to know. Can we detect inevitable failure earlier? Yes, we can identify earlier what is the constraint it was not satisfying. Most constraining variable. So this we are having two types: most constraining variables and least constraining variables. In the earlier example, what we used the least constraining variable. The least possibility we were selected, and also we can select the most constraining variables also. A good idea is to use the tiebreaker among most constraint variables. So what are the most constraint variables you can assign for the remaining variables? And also we have least constraint variable also. So what is the least possibility for giving the value? You can give that value, and remaining values you can give the last priority. That was we are used in solving the problem of cryptarithmetic. What you used there? We are having a domain. In that domain, you are selecting the least value, least possibility value. You are giving the first priority, and highest possible values also we can give the priority. That it will be the different, right? Summary. So these constraint specification problems are special kind of problems. What we learned we are saying, and mainly we are discussed about the depth first stage and backtracking and variables ordering and forward checking, filtering, how we are going to filter, what are the constraint propagation, what is the arc consistency, path consistency, node consistency, and k consistency, and then we are used minimum conflicts that are occurred in the effective of practice. And if you practice more and more problems in cryptarithmetic, then you will be able to understand how we are applying the constraints while you are solving a problem. So this is for you for your self-learning, how to apply the constraint specification problems on different kinds of problems. And that's what I told for you. We can solve the different kinds of problems like send more money, and here I explained 2 to 4 these kind of problems. You can also practice your self-learn, and this is a 4 queen self-learning for you. And the 4 queen problem also you can solve with the help of this, because this problem is also having some constraints. So no attack should be the diagonal, the queen should not be appear. So like this the constraints was kept for you for this game. You can play this game and you can solve these kind of games with the help of those constraints what it was kept, the initial state and goal state. By satisfying all the constraint you need to reach for the goal state. Okay, this is the end of our session, and I hope you understand, and good luck.